Special relativity is one of the most profound and deep insights that we have into the very nature of reality. It's a meta principle that underlies absolutely all of our knowledge and everything that we know. Space and time seem to be intrinsic to absolutely everything, including human perception. And it is one of the greatest ideas that humanity has ever came up with. And I say humanity because although Einstein was the synthesizing agent that brought them all together, he, nevertheless, was standing on the shoulders of hundreds of giants, and only by their previous acquisition of knowledge was he able to create and come to the conclusions of special relativity, as insanely beautiful as they are. Now, I want to make this video for two reasons. The first is that I want to share special relativity with as many people as possible, because I found it when I was studying it or trying to learn it, it was one of the most difficult subjects to sort of come to conceptual grips with. So it was very difficult to wrap my head around it, and I want to share it with you in a way that you'll be able to understand it, even if you don't know any mathematics or any physics for that matter. You only need to equip yourself with maybe 4 conceptual ideas: a reference frame, the speed of light being constant, space, and time. And with these 4, we can arrive at the consequences of special relativity. And the second reason I'm making this video is because I believe that special relativity establishes as a fact a universal ground floor or fabric of reality that we all share as common, that we now call space-time. And not only is it a universal ground floor that we all share, but it is the very fabric of existence itself, because space and time seem to be the absolute essential or fundamental necessities for there to exist anything at all. So not only does the external universe need space and time as functions or modalities of its workings, but so too does the human perceptual apparatus require space and time to know anything. So you'll notice your conscious experience is always fundamentally modulated or formed by the concepts we call space and time. So consciousness, you could say, is spatial because you know it as a space, and time because you move through time. If the universe were frozen, you wouldn't know anything at all. Nothing could come to be known if the universe were a static no thing. So time seems to be essential, and space is also essential, and special relativity welds these together and says that they're the fabric of reality itself. So how do we get there? How do we understand special relativity? Well, basically what Einstein did is he took 2 ideas, the principle of relativity, which was known since Galileo, probably earlier maybe, and the fact that the speed of light is invariant, or it never changes. Invariant just means it does not vary. So Einstein forced these 2 ideas together and blew them up, and in the rubble of those ideas lay space and time as we used to know them in Newtonian absolute terms, but a phoenix rose up out of those ashes, which is what we now call space-time. Or mathematicians like to call it the metric field, which is the mother of all fields. And we'll get into that when we talk about fields later, but we just want to get special relativity down right now. So, the principle of relativity. Relativity at its most basic is the idea that the same subject can be represented in a multiplicity of ways without any loss to that system or that scenario. So there's different ways you can look at it, each of which will have to agree on an underlying, unifying something. Relativity brings in the notion of symmetry, that you can have a change without change. So you can think of it this way. If I have a triangle, maybe I'll animate this. If you have a triangle and you rotate it 120 degrees, you've changed it, but you've changed nothing. It's still a triangle, it's still sitting on its bottom edge. You've rotated it, so you've changed it, but you've really changed nothing. So you have a change without change, and this is the essence of symmetry. And you can do this with squares. Actually, a sphere is perfectly symmetrical because you'll change a sphere, you can rotate it on any axis you'd like, and it never changes a single thing. The first thing we have to do to understand relativity is equip ourselves with the notion of what a reference frame is, or a frame of reference. And to do this, we can go all the way back to Aristotle if we want and look at his cosmology. Because in his cosmology, he had an Earth at rest and then an entire cosmos that moved around that. So in this view, in this cosmological view, you can see two valid frames of reference or ways of looking at the world. A frame of reference at rest and a frame of reference in movement. Fast forward some 1600 years or what have you, and Copernicus, on his deathbed, puts forward his heliocentric model of the solar system, and by doing so, he populates the universe with a multiplicity of valid frames of reference from which to view the world. So no longer did we just have Aristotle's two valid frames of reference, at rest and in movement, but now we have a multiplicity of reference frames. After Copernicus evolved the idea of a reference frame to show that there's multiple ways in which you can see the world, and each of them is a valid way to look at it, Descartes came along and he geometrified it, and Descartes added algebra and geometry together and formed his Cartesian coordinate system, where you now can have an X, Y, Z coordinate system, which now is like a really mathematical fancy way of having a reference frame. And you can have two, and then those two mesh together, and how they work is what we're trying to get at. So then Galileo comes along, and Galileo knew the principle of relativity, but he actually formed a really simple and beautiful thought experiment that explains the principle of relativity very well and gives you a very intuitive notion of what it means to have a valid frame of reference. So basically, Galileo has you imagine that you're below deck on some windowless ship and you're traveling at a constant speed, say 50 knots or whatever you'd like, and you're traveling at this constant speed, and say the sea is very calm. Inside this windowless cabin of the ship, there would be no experiment that you could do that would prove to you that you are moving, because in your frame of reference, absolutely everything is moving with you. So you drop a ball, it goes straight down. No matter what you do, you won't be able to prove that you're moving unless you can open a window and see that you are. But in so doing, you bring another frame of reference into the calculation, and then you can know that you're moving. Now, if you're a person sitting on the beach and watching the ship, you would know that the ship is moving at 50 knots per hour relative to you, and that if a person were to drop a ball in that frame of reference, it would make a V shape and travel a longer distance than it would if you were in the frame of reference in the ship. So this is where things start to get a little bit bendy, or a little bit hard to wrap your head around. So each frame of reference is a valid way to look at the world. Now let's imagine instead we turn the ship and we start sailing into the sunset. And you have one person sitting on the beach, and you have one person, we'll put him on top of the deck now, and he's sailing into the sunset at 50 kilometers an hour. So here's where the speed of light comes into play, and this is where space and time needs to bend. If you were able to do an experiment where you measured the speed of light coming at you from the sun, you would measure it as the speed of light. If the other person is on top of the ship and they are sailing into the sunset, and they too can measure the speed of light, you would think that you would measure 50 kilometers more, because your speed going into the sunset and the speed of the light coming at you would add up. So you should get something like 300,050 kilometers per second, if you will. Or say you're moving 50 kilometers per second on the boat. That's pretty fast. But anyway, that's why the speed of light's insane. Anyway, the main point here is if you're on a ship moving at the sun, compared to sitting on the beach not doing anything, the main point is you believe with the standard addition of velocities that you would measure different speeds of light. But this is not what takes place. In whichever frame of reference we measure the speed of light, we always find it to be 300,000 kilometers per second. So it's always traveling at this speed, no matter what. And if you're moving at it, if you're moving towards it or coming away from it, it doesn't matter. You'll always find it to be 300,000 kilometers per second. It is a universal constant, and the fact that it's invariant and it doesn't change between reference frames, this is the sort of crux of where special relativity gets different, because you go, well then what is light doing between reference frames? Like, how is it that it stays the same speed even if you start flying into it and you still measure the same speed? Like, what's going on? You might be asking, what is light doing between reference frames? And the answer is light's not doing anything. What's happening is space and time are modulating themselves to accompany this stubborn angel we call light. So space and time parameters need to modulate to allow the speed of light to stay constant through reference frames. So a way I like to think about it is, say you have some godlike DJ and he's got 3 function knobs on his turntable. One is a slider, and that's your volume, of course, and this thing's cranked. We'll put it all the way up to 11, and say this volume slider, it can't move. You can't change it at all. This volume slider represents light. You can't change it ever, because for some odd reason, it's just a fact of the universe. Energy momentum traveling in the electromagnetic field as self-oscillating electric and magnetic fields oscillates at 300,000 kilometers per second in this field. It's just the way it is. We don't know why. It doesn't change. Whatever. Volume slider up, 11. Then he's got 2 knobs, and they're both sitting straight like this. One's labeled space, one's labeled time. Because your volume knob won't change between reference frames, this light won't change. When the light moves between reference frames, it's as if this godlike DJ grabs only one of the knobs, because the other one moves in conjunction with it automatically. And so he just grabs one knob and he just turns down time, which contracts space, and it allows light to stay the same speed no matter what it's doing. So you have these like godlike superpower to change space and time. So basically, that's it. In order to accompany Maxwell's stubborn angel light, we need to get rid of our absolute notions of what we think of as space and time. And not only that, they are inexorably linked together. You have to weld them together. In order for light to stay the same speed through reference frames, space and time need to be welded into a single unified field where they now become different aspects of one and the same four-dimensional ground. And so when you turn down the time, it contracts the space, and when you turn it up, it comes back. They are linked underneath. You have to, one changes the other no matter what. It's as if they borrow from one another to keep the speed of light constant. So space and time need to get thrown out the window, but they get resurrected by the phoenix of space-time. That is the basics of special relativity, the result of which is the establishment of the ground of the universe as space-time itself. And not only that, but a malleable, wave-like, mushy, cosmic ocean of space-time. So everything in this fabric now waves. We have gravitational waves, electromagnetic waves, quark and gluon waves, or maybe wave functions is the better term for that one. Anyways, that's the gist of special relativity. I hope this helped you understand it more intuitively just through conceptualizations and thinking. And if you enjoyed this video, give it some love, hit the like button, all that nice stuff, and subscribe for more content in the future. And as always, thanks for watching. I think that's it. It's difficult shit. Difficult shit. Peace.